This conference will now be recorded.
I'd like to welcome you to our fourth in a series of educational seminars on network design for security applications. In the previous ones, in Seminar 1, we looked at an overview of network requirements for security applications. In Seminar 2, we focused on PoE, a process component. And in Seminar 3, we looked at network switches, which is an equipment component. Today, we're going to go outside the IEEE standards using IP-PoE. There are two reasons for this. First is historically, for approximately 40 years, Coax cable was the primary method for CCTV transmission. That's perhaps millions of installations with existing coax with a transmission distance of 750 feet to potentially 1,000 feet, or 2 to 3 times the distance of standard IP-PoE transmission, are still in existence today. In these installations, cameras, recording equipment, and viewing stations are already in place, and it becomes impossible, if not difficult, to move them. Other considerations involve around the problems in pulling cable out of existing installations, particularly in schools and hospitals where asbestos and other health checks may be required. The second applies to UTP or Ethernet cable installations, where IP-PoE installations require distances over the standard limit of 328 feet, 100 meters. So let's take a look at what is Ethernet and PoE standards for UTP with regard to distance.
This conference will now be recorded.
I'd like to welcome you to the fourth in our series of educational seminars on network design and application for security applications. Regardless of whether you're using camera recording or viewing specifications, all of these are dependent upon network performance for their quality and reliability. All are affected by network transmission. And for you, the viewer, regardless of camera recording or viewing specifications, or whether you're in sales, design, installation, or technical support, everyone plays a part, an important part, in assuring the most reliable security system performance with the least amount of problems. Our hope is in attending this fourth seminar, you'll choose to see the remaining 4 seminars or the previous ones, and it will help to make your job easier and more productive. In Seminar 1, we took an overview of all the aspects of networking for security applications. In Seminar 2, we moved on to the specifics of PoE, or what we call a process component within networking. In Seminar 3, we investigated the role of network switches, or an equipment component. Today, we're going to go outside the standard IEEE specifications for IP and PoE extenders. There are 2 reasons for this. First, historically, for over 40 years, coax cable was the primary method for CCTV transmission. Perhaps today, there are even millions of installations throughout the world that still use coax cable and exist at a distance of between 750 to 1,000 feet, or 2 to 3 times the standard distance that's used for IP-PoE transmission. As these are already in place, it becomes more difficult to remove them. And in doing so, we could cause additional problems and expenses, particularly where schools and hospitals are concerned, and the removal of cable within a wall might result in the requirement for health checks due to asbestos. Even when we look at new installations using UTP or Ethernet cable, it may be that the ability of transmitting PoE and IP is restricted by where we can replace power sources, or in the case of where the camera is located, where power sources are just not available. So extended distance becomes a key component of these. We're going to talk about today standard distance versus extended distance transmission, how extended distance affects bandwidth, how extended distance affects PoE, Ethernet and PoE IEEE standards, differences in cables such as UTP and STP cable, and the use of non-standard cabling for IP/PoE applications. We're going to define an extender, and we're going to define also the various elements such as a repeater that will go in for extended distance. So let's look at standard distance versus extended distance transmission. As we spoke about before, within the IEEE standards that establish the transmission of IP and PoE, they used Cat5 cabling, and they were restricted to a distance of 328 feet or 100 meters. And this allows us to determine when we have a particular source, such as the port of a network switch, with a particular bandwidth and PoE, what the result will be after it travels down that cable for 328 feet. The first thing we need to take into consideration is the actual value of 328 feet. In reality, there may be additional resistance within the cable itself, and this results from how the cable itself is installed. Regardless of the quality of the installation, cable bends, and when these bends occur, they increase the resistance within the cable itself. So it's good practice to apply what we call the bend ratio within the cable, and instead of looking at it in terms of 100 meters, apply a distance of about 90 meters to take into consideration the additional resistance within the cable. The minimum bends for category cable are calculated at 4 times the cable diameter. And this is because both of this affect the resistance of the cable. So when we talk about this and we talk about the extended distance, and the infrastructure, including the cables, you have to take into account the bend performance. How extended distance affects bandwidth? Well, we addressed this previously in our last seminar about networking, and we spoke about the transmission of packet sizes. We already know that there's a limitation using standard network switches in that at 100 megabps, the packet size is limited to 1518 bytes. And we also know that depending upon the megapixel value of the camera itself, the packet size could be a lot greater. So we spoke about the fact when there's a mismatch with greater packet size than what can be accommodated at the port of a switch, the picture can look pixelated, or in the very high levels of megapixel cameras, the picture itself could look scrambled. Now we're going to talk about it in terms of bandwidth. And that also creates a problem in that when enough bandwidth is not available to be properly processed by the source, let's call the source now a VMS system running on a computer or an NVR, the picture will look frozen, blurred, or choppy in movement. One of the primary things that we have to take into consideration when we extend cabling is the ability of maintaining a fixed data rate. And this is important in your consideration for your selection of extended equipment. Your extended equipment must maintain a fixed data rate, either specified at 100 megabps or 10 megabps at whatever the distances are that are specified. And this is important within our selection, because if this fixed data rate is not maintained and instead a variable data rate is used, you could get the condition that we spoke about frozen, blurry pictures or choppy movement. How extended distance affects PoE? Well, again, last week and a couple of times when we spoke about PoE, we spoke about the timing element and all the complexities that are involved in a source, a PSE, maintaining and creating PoE that can be received by the PD, the camera, in order to turn on. And we spoke about this not only from a level standpoint, but also a timing standpoint. Well, resistance within the system affects both. And we know that the longer the cable, the more resistance there is. Well, that applies to extenders and anything that's placed within the system itself, because any object that's placed within the transmission path is going to increase the resistance. So the goal is to basically provide the least amount of obstruction to the transmission of PoE and data within the system itself, because at the end result, and we're going to look into this, the standards that require the PD to turn on when it receives its information from the PSE, as you're seeing in this chart, must be maintained. If they fall below their certain levels, the system will just not work. What are some of those things? Well, we spoke about this again during our POE session. So if we talk about the different classes of POE, and I'll use as an example again the 802.3AF standard, if we're at class 0 or class 3, the source is 15.4 watts, and over 100 meters, 328 feet at Cat5E or Cat5E, Cat6 cabling, the PD, the camera, is expected to receive 12.95 watts. Just as important is the range of voltage that must be received. And as you can see here, the PSE will put out a range of voltage between 44 and 57 volts DC, and the camera itself must receive something in the range of 37 to 57 volts DC. And as we spoke about it, we also indicated that this amount of voltage is not always consistent for every single manufacturer, and that it could range more towards the higher end than the lower end. And as you can see, when we shift over to 802.3 AT and the different standards for POE that come after that, the lower end is actually raised to 42.5 volts DC. So regardless of what we're putting in as an extender or repeater or any other device that increases the distance, our system really doesn't care. It expects to see this in order to work. So the ability of maintaining this becomes a critical component. Why? Because POE systems are designed for standard distances of 100 meters. They're not designed to have variables in it of any extended ranges over that. So depending on the PD load, the POE reach can be much longer than 100 meters. The key would be at the PD, we need to have the required voltage and the required power. So much of this again goes back to the cabling. So it's really, extended distance is really a marriage between the cabling and the devices that you use to extend the distance itself. And as you can see from this chart, that basically we operate in the security industry in the range of Cat5E, Cat6, Cat6A. Notice I eliminated Cat5 because basically that's not really sold anymore. And the differences between that have to do with the gauge of the wire. So quite often we're asked, well, what's the difference between the specifications of Cat5E and Cat6 in terms of performance? Well, first of all, Vigitron products are always designed to work at the lowest end of it. So right now, our standard for testing and determining different distances are based on Cat5E. That's a distinct advantage because now if we shift and somebody puts in an installation with Cat6, you can see because of the difference in gauge and thereby offering less resistance, there is a general increase in performance. We can't be specific about that, but basically it's around a 7% increase in performance. We also know that the POE standard takes into account two different modes of operation. We express that as mode B and mode A. So it's important that the devices that you use to extend distance or affect the transmission at more than 100 meters be compliant to both mode A and mode B. Another question we get asked quite often is what is the difference between UTP cable and STP cable? So UTP cable is what we're most familiar with, unshielded twisted pair, versus STP cable, which is shielded twisted pair. Well, again, the standards were designed around UTP cable, not STP. STP cable, which is used a lot for outdoor installations, and has greater ability as far as grounding goes to shield it from both interference and possibly surges, also has a great deal more of capacitance in it due to its shielding. The capacitance has a big effect on reducing bandwidth. So you have to take that into account. In general then, and because STP has many variations in terms of the types of shielding applied, it's impossible to give a general type of figure as to how much this reduction is. But there is a reduction in distance as far as differences between STP and UTP cable goes, keeping in mind the standards were developed around UTP. Then we get into the areas of non-standard cabling. Once again, as I keep emphasizing in this, the standards were developed around CAD5 cabling. CAD5 cabling, 8 individual wires, 4 pairs of wires. So everything that's related to the ability of transmitting bandwidth and PoE is centered around this particular cable. When we go to differences in cable, and the most likely ones are coax and single pair, they have a commonality. And that commonality is that they are only a single pair. Single pair cable is obvious, but also coax cable is just a center conductor and a shield. So as a result of it, we have some significant limitations. The reduction in the amount of pairs used also reduces bandwidth and reduces PoE ability. So we have to take that into consideration when we're extending these different distances, that not only are we working with the decreases in performance based on extended distance, but now if we take single pair and coax into consideration, we have further considerations as far as reductions in bandwidth and PoE depending upon the type of cable used. The main thing that we have to realize is there's no released IEEE standard for Ethernet transmission and PoE over coax or single pair. Further, when we get more into coax, we find out that there are many different variations of coax. RG6, RG11, even though the standard is RG59. Also, even within a single family like RG59, there's differences in shielding. And all of this can affect performance. In some cases, if we have aluminum braid shielding around an RG59 cable, you'll find that it can't be used at all for the transmission of IP or PoE. So the resistance of the cabling itself can vary greatly and affect its performance. In general, as we spoke about cabling, if we're talking about UTP cable, because of the use of multiple cables, we have the ability of transmitting power a longer distance, but at a reduced bandwidth. If we talk about coax, we have a great deal of resistance to power, but it has an increase due to the size of the cabling to bandwidth, so we can transmit bandwidth a longer distance. Single pair wires can be used to handle IP video and PoE, similar to coax. Both of them run over the same conductors. The difference is in single pair, there are different single pair wires at different sizes. So some of you might be aware that CAD cabling is really 24 gauge. In many cases, when we see alarm installations, they're 18.2 or 16.2. So again, within the single category of single pair wiring, we have several different performances based on the gauge of the wire as to how it will respond to data or PoE transmission. And again, looking at this chart, we can see that those differences are expressed in terms of resistance. Now, going back to what we learned in the session on PoE, we spoke about the ability of having the greatest amount of power can flow when the source resistance is the same as the resistance within the cabling being transmitted and the point of reception. So when all of that is equal, we get the maximum amount of power coming through. And that resistance that's expected by the PD is essentially 22 ohms. It's sometimes expressed at 22 K ohms when we talk about 1,000 feet of cable. So you can see within the differences of gauges how this breaks down in terms of resistance and how that resistance can affect transmission. Pardon me. So 18.2 wire resistance is 75% less than 24.2, resulting in longer distance in PoE transmission. So the smaller the number of the gauge of the wire, the less the resistance and the more the PoE flow. So in general, as cable distance increases, cable resistance increases and the voltage and power available decreases. So what is an extender? Well, an extender is a device that extends transmission range of Ethernet and PoE beyond 228 feet. An extender should be installed at both ends of the long cable. The extender is affected by the PoE source power, cable length, cable type and quality, and power required by the connected device. What is the advantage of using an extender and when is it used? Well, simply put, since extenders are used at each end of the cable, it means that the cable itself could be put in areas that don't require much attention, such as conduit. Furthermore, if we need to service the system for any reason, the extenders are easily accessible, being at both ends of the cable. When we talk about coax, an extender or single pair for that matter, the extender has a dual function. And the dual function is not only to extend the cable, but to convert the signal to travel over those two types of cabling. So regardless of the length involved, when we deal with those types of cables, we're going to need an extender, even if the distance that we want to extend is under 328 feet. And these are various examples of most of what Vigitron offers in their extenders in both regular, mini, and weatherproof applications. Once again, when we look at extenders for coax, there are a couple of things to keep in mind. Number one, they're mandatory. We have to convert between Ethernet cabling and coax cabling. So the extender is both a converter and an extender. But because of the fact that coax cabling is a single pair, we are restricted to 37 watts. And therefore, coax cabling cannot be used in applications where the connected device, such as a 60-watt PTZ dome, requires more than 37 watts, particularly those in the 60-watt range. What is a repeater? Well, a repeater, by its very nature, repeats the signal. Because of that, it needs to be positioned within 328 feet of the source and the connected device. So we have a restriction. So what does a repeater do? Well, it's a single device that extends the cable itself. And therefore, it's one device compared to an extender, which requires at a minimum 2 devices. The problem with extenders is if we are dealing with areas where the cable runs that are not accessible, we cannot position the repeater in an area that we can't get to, such as a conduit, and that creates a problem. One other advantage is that a repeater has over an extender. All this time when we've been talking about extenders, we've touched on the subject of bandwidth. Well, extenders are limited to 100 mega PBS. And the reason for that is because of the limitations of the cable itself and the interaction. So let's say we have an application, as we're shown here, between 2 network switches, where we want to extend the uplink and maintain 1G. Well, a repeater, being limited to one spot and repeating in the middle of the cable run, can do that. So repeaters have the advantage of, again, a less costly solution, mainly if your extension is under 328 feet times 2 or 656 feet, and the fact that it also can operate at 1G modes. So this is a summary of the differences between extenders and repeaters. So extenders are the most cost-effective solution for extended distances over 656 feet. They're the safest solution when conduit is used. They're the only solution for the transmission of single pair and coax cables. What's the con? Their bandwidth is limited to 100 megabps. Repeaters are the most cost-effective solution for UTP, notice not coax, but UTP, for distances of 656 feet or less. They can be used if the midpoint of the cable run is accessible, and they are a 1G solution for connecting switch uplinks. We also have another type of repeater, which is called a drop-in insert. And this essentially is basically a 3-port switch, which operates as a repeater itself. So it has the ability of having single cable runs and drop and repeating by the connection of other devices. So it will allow for a single cable run with multiple devices separated by 328 feet. Once again, notice the requirement to insert it at 328 feet. The Vigitron drop-in inserts can resolve up to 9 IP addresses, eliminating the need for a network switch. So if I have a NVR or I have a VMS system that has a single input and I only have 8 cameras connected to it, I can essentially rerun that as a single line and eliminate the network switch. But I also have another application. Let's say I have a network switch and I need to put in more cameras, but I have a limitation in the number of ports of the network switch, and I don't necessarily want to replace the network switch, or my rack space won't allow for the addition of another switch. I can literally expand every single port on my network switch by 8 ports using the drop-in insert approach. So why do I need any of this? Okay, so well, why do I need it? Aren't there standard switches that claim they can operate at extended distances? Aren't there UTP cable manufacturers that claim they can operate at extended distances? So why do I need extenders? Why do I need repeaters? Well, once again, we have to look closely at the specification of these claims. In the previous 3 seminars, and in this one, we've stressed that in order to have reliable operation, the standards that are involved in the performance of bandwidth transmission and PoE transmission that were applied for under the IEEE standards that develop this must be maintained. You'll notice if we look at any of those switch specifications or any of those claims by other cable manufacturers, they don't address the idea of packet size. They don't address the idea of bandwidth. They don't address the idea of maintaining the requirements of PoE. And therefore, the resulting PoE and bandwidth at the other end of the cable connected to the camera may not be sufficient for reliable operation. And as we learned in the PoE segment of these seminars, is that once we lose that connection with PoE, the source does not necessarily start up the system again, and therefore the camera can remain offline for considerable periods of time. So different manufacturers with different devices have different requirements. And therefore, in many cases, when we take these variations into account in the design of IPPoE products, combined with this, you have a high degree of possibility that these non-extended, extended claims by switch or cable manufacturers may not work or may not work reliably. So why doesn't your network switch work for your application under these circumstances? Well, it may be the way the switch specifications are determined, the port size limitations, the switch fabric that we spoke about, the compliancy to PoE standards, and the ability to maintain connections, or specification confusion and special features. So all of this, once again, gets back to the fact that whatever your network requirements are, they are specific for your application. and there is no cookie cutter approach to the design of networks. If you have 100 different projects out there, I can assure you that each one of these 100 designs will be significantly different from one another. And that's why Vigitron offers our design center services. For 9 years, we have worked with major manufacturers in the areas of IP cameras, access control, LED lighting, wireless, in order to determine not the performance of their equipment, but how their equipment operates within a network environment. And from that information, we have created a team of engineers called the Design Center that will provide for you bills and materials specific to your application. And we offer this service free of charge and without obligation. Now, why can we do it? Well, basically because of the Vigitron advantages. We are the only manufacturer that offers multiple products in every single category that involves a network. So we are the only manufacturer that can provide a complete network solution and sometimes even multiple designs. And that's important for another reason, because it avoids finger pointing. When you get different components from different manufacturers and they don't work, and all of a sudden you're calling these different manufacturers and they're finger pointing. It's not my problem, it's their problem. All of our products are designed, tested, and quality controlled in the United States with local design and service support from skilled network engineers. And because of all this, without exception, we offer the longest warranty in the industry. It's applied completely across every product in our line, and that's production lifetime and plus 3 years. So even when a product goes out of production, you still have a full 3-year warranty. So once again, we thank you for taking the time to participate in viewing this webinar. If you have any additional questions, you need more information about our products and services, our design center support, we encourage you to email support@vigitron.com, or you can contact me, Neil Heller. My information is here. We thank you. We hope you'll continue to watch these seminars. And again, please do contact us for any of your project needs.